more different derivative rules that will make it easier for us to compute different harder derivatives. So in the previous video, we talked about the constant rule, the product rule, the sum and difference rule, and the constant multiple rule, the CMR. So now we're going to be talking about a few more, like the product rule and the quotient rule. These are really important rules for derivatives, and they will make it easier for us to compute different composite functions, or I mean, not composite functions, other functions which are more complicated. So let's start with the first one, the product rule. So the product rule states that the derivative of, say, f of x times g of x times g of x is equal, that's a multiplying sign, times g of x is equal to the derivative of the first function times the second function plus the derivative, the first function times the derivative of the second function. So we can try an example. 3x minus 2x squared times 4x minus 10x squared. So you could do the FOIL method and then the power rule and the sum rule. Oh my gosh, that is a lot of work. So I'm just going to try using the product rule. We can say that this is equal to f of x and that's equal to g of x. So we can take the derivative of the first function, which is 3 minus 4x, all from the power rule, and then multiply it by the first function, add it to the derivative of the second function, which is 4 minus 20x times the first function. And good news, for the AP exam, you won't need to simplify this at all. You can just leave it as is, as like this, and you would get the full mark. So you don't need to spend too much time simplifying. Okay, so let's talk about the next one, the quotient rule. This is a more confusing one. For the first one, it didn't really matter what order you did it, the derivative and the other way around. But for this one, order does matter. If you have the derivative of this thing, f of x over g of x, it is equal, and you have to understand this, the numerator's denominator, the numerator's derivative times the denominator minus the derivative of the denominator times the numerator, all over g of x, the denominator squared. So if you had 5x squared minus 1 over x cubed plus 1, the derivative would just be 10x times x cubed plus 1 minus 3x squared, and then we would have 5x squared minus 1 all over x cubed plus 1 all squared. So those are the two other complicated rules. And now let's just talk about the derivative of trig functions. So in the previous video, we talked about the sine's derivative is cosine, and cosine's derivative is negative sine. So how do we compute the other ones? Well, we can use these product and the quotient rule to solve these. Let's start with the tangent. The derivative of tangent is equal to sine x over cosine x, right? So let's just use that rule. So let's just plug in sine x over cosine x. According to the quotient rule, we take the derivative of the first and multiply it by the denominator. So we get cosine squared x, and then minus the derivative of the second one, which is a minus sine x times that. So it'll just be plus sine squared x all over cosine squared x. This would just be 1 by the Pythagorean identity, and the reciprocal of cosine of x is equal to secant of x, so this means this is equal to secant square x. So tangent's derivative is secant squared x. Now let's look at the secant itself. So secant is the reciprocal of cosine, so we can just write this as 1 over cosine x. and this would just be equal to the derivative of the first function times the second function. So this would just be 0 because of the constant rule, minus the derivative of the second function, which is sine, times 1, all over cosine squared x. So this is equal to sine x over cosine squared x. We can separate the cosine x into cosine x times cosine x. So we have so we have 1 over cosine x times sine x over cosine x. So sine x over cosine x is equal to tangent x, and 1 over cosine x is equal to secant x. So this is equal to secant x tangent x. So secant of x's derivative is secant x tangent x. What about the other two functions, cosecant and cotangent? I'll just give you the answers here, but you can try solving them on your own. So these are the other four trig functions as derivatives. It's good to memorize these ones. It might be helpful. You will get tested on this in the AP exam as well. So just revise them. So let's talk about higher order derivatives. So we have f of x, for instance. Its derivative is f prime of x. The derivative of that is equal to f double prime of x. And you can go on with the apostrophes. And you can also write it as you have y prime, y double prime, y triple prime, y quadruple prime, and so on. You can do y dy dx, d squared y over dx squared, d cubed y over dx cubed, and so on. And then you can have dxy, dx squared y, you can put the y in parentheses, dx cubed y, and so on to like dx to the nth y. This is a dny over dy to the n. So these are different ways of writing the different derivatives. You can compute each derivative by itself and then take its derivative and take its derivative until you get to that derivative which you're desiring. But why is this useful? So we will be using this in the application of derivatives when we're trying to find minima and maxima of functions, the relative, the absolute minima, the absolute maxima, the relative minima, the relative maxima, where the the graph changes to a different type of a shape from like up to down, concave up to concave down. So that point there would be the flipping the concavity. And this is when the second derivative of any function, when that is equal to 0. The minimum maxima are when the derivative is equal to 0. And so you can use these derivatives to find out how to sketch a graph of a function without really needing to know what the graph looks like. So that is why derivatives are so useful. And another thing is in physics. So you have the position function s of t. Its derivative is the velocity. So this is s prime of t. Its derivative is v prime of t, s double prime of t is the acceleration. So this is how it is applied in physics as well. So that is the basic idea of derivatives. These three videos, the one before this and the one before that, are an introduction to derivatives, how to compute them and the different rules of them, so that you'll be able to easily compute any derivative when you're tackled with it. And there are other ones which we'll be learning. One other rule you have to learn is the chain rule, which will be coming up soon. So thank you for watching and have a nice day.